May I request Sunita Mongjam to deliver our topic Vermicomposting of organic solid waste by using s.kula, a sustainable living in post-Covid-19 pandemic.
Respected dignitaries, esteemed participants, ladies and gentlemen, a very warm good morning. I am Sunita Mongjam, Zoology Department, SK Women College, presenting my paper on vermicomposting of organic solid waste by using Escherichia foetida, a sustainable living in post-COVID-19 pandemic. A rapidly increasing population generates enormous quantities of municipal solid waste, causing serious environmental hazards and health problems. Meanwhile, municipal solid waste is highly organic in nature, so vermicomposting has become an appropriate measure for safe, hygienic, and cost-effective disposal of organic solid waste. Vermiculture means scientific method of breeding and raising earthworms in controlled conditions. It aims at creating improved conditions artificially so that earthworms multiply in shortest possible time and space. Vermicomposting is a simple biotechnological process of composting in which earthworms are used to enhance the process of organic waste conversion and produce a fertile organic manure termed as vermicompost. It is an eco-friendly technique for treating organic waste and can be taken up in every house to harvest organic manure for their own use. The study aims to bring proper management of organic solid waste and the production of more organic manure through vermicomposting using species Escherichia foetida. Continuous use of chemical fertilizer causes loss of soil fertility, which adversely impacts on agricultural activity. So, people are opting the use of organic manure in plant nurseries, kitchen gardens, and crop fields. Vermicompost is a good source of plant nutrient as it provides all nutrients in readily available form. Application of vermicompost in soil improves the growth and yield of different field crops, vegetables, flowers, and fruits. The benefits of utilizing vermicompost are manifold. For example, in farming, has lesser investment on fertilizers, increases soil fertility and productivity, and gives better plant growth and crop yield. Regarding industries, it is a cost-effective way of controlling pollution. In general, vermicomposting can be an alternate source of income to everyone. It is an environment-friendly method of converting organic waste and garbage into organic manure. And it is a boost to the economy as well. Collection of waste. Waste samples weighing about 125 kg were collected from the residential area of Manipur University campus in Imphal West, Manipur. Processing of sample. The waste sample were characterized by segregating and discarding the non-biodegradable components. The biodegradable components were mixed with cow dung slurry in the ratio 3:1 and kept it covered with black plastic sheets for 21 days. Thermal stabilization was done prior to introduction of earthworm into the pre-composted medium. Experimental design. The research work was done by taking an experimental study which is carried out in Kulite boxes of 24 inches length, 14 inches breadth, and 12 inches height. 500 adult earthworms were introduced on the top of the pre-composted substrate in each of the boxes. All the boxes were covered on the top by jute cloth and again covered with wire mesh to prevent and protect the earthworms from the predators. The process of vermicomposting were carried out for a period of 60 days. The temperature and moisture content were maintained by sprinkling adequate quantity of water at frequent intervals. The harvesting of vermicompost and the total earthworm biomass, individual body weight, total number of juveniles, adults, and cocoons were carried out at the end of the experiment as per Patnaik and Reddy 2009. Physiochemical analysis. The homogenized subsamples of each composted substrate material, 100 gram dry weight, were collected undestructively on the 60th day from each box, and the compound samples were made, which were processed for analysis of organic carbon and total nitrogen, phosphorus, potassium, iron, copper, zinc, and manganese. In the result, Table 1 shows the different physical parameters of the substrate and its vermicompost. Table 2 shows the growth parameters of Escherichia foetida during the process of vermicomposting. Table 3 shows the nutrient analysis of vermicompost using municipal solid waste. Thus, finally, vermicompost collected on the 60th day has higher contents of nutrients like nitrogen, phosphorus, potassium, iron, manganese, copper, and zinc. Thus, it is seen that vermicompost has higher content of nutrients when compared to the substrate. The findings show that the species of earthworm, Escherichia foetida, has high potentiality of converting organic waste into vermicompost. Thus, vermicomposting can be taken up in every household with the available waste generated from kitchen, garden, agricultural field, etc. This vermicompost can be applied to the nursery plants, flower pots, kitchen garden, and even crop fields to get good yield. Thus, Escherichia foetida can be utilized in vermicomposting as it is a good surface feeder and dwells in organic waste. It can live in a wide range of climate type and is active in all the season. Vermicomposting can be taken up all round the year as an income generating activity in the households with minimal investment even in the post-COVID-19 situation. This will give livelihood support to family as well as help in reducing pollution to some extent. During and after COVID pandemic, people can take up this cottage industry as a recreation for production of organic manure, economic support, and also maintaining a clean environment. Thank you.